and share my screen. Okay.
When after you're done teaching, could you open some breakout rooms so that we could do it with a partner?
Sure, that's fine. Just so you know, I might not be available right afterwards, but I'll leave my Zoom open for you guys if you want to work with somebody on it. That's fine. Yep. Okay, so we are going to finish our 6.5 notes. Our 6.5 was over analyzing and sketching graphs. And so we did a lot of analyzing yesterday. We looked at some graphs, we deciphered what they're trying to tell us. We didn't do any sketching though. And so that's kind of what we're gonna do today. So we looked at graphs that were already sketched. We saw, different types that are linear and nonlinear, and not just nonlinear, but like what's happening to that rate of change. So in graph A here, it was increasing at an increasing rate. We talked about, I think I put it at the bottom of your notes, we talked about the differences between increasing at an increasing rate, increasing at a decreasing rate, decreasing at an increasing rate, and decreasing at a decreasing rate, and what those would look like, and be expected to be able to draw a graph, sketch a graph like that on your test on Tuesday next week. So let's go and practice sketching right here. We finished up with the last problem. This one says, sketch a graph that represents each situation. Example A. A stopped subway train gains speed at a constant rate until it reaches a maximum speed. It travels this speed for a while and then slows down at a constant rate until coming to a stop at the next station. Okay, change my stylus here. It's not working too well. Okay, so we're looking at speed over time. So what's the speed of the subway car at the beginning of the story?
Maximum speed. No, it's gaining speed.
0.
At the start of the story, it should be 0, right? It says it's stopped. So to start the story, I'm going to start here at the origin, right? I'm going to start with my speed being 0 because the subway car is stopped. And so then, as Cooper mentioned, it's going to gain speed at a constant rate. That means it's going to be linear, right? If it's got a constant rate, gains speed. Okay, so that would look something like this. I don't know. I guess we could just say, again, this is a sketch. This is not exact, right? I'm just drawing that it's gaining speed. There's not even any numbers over here because it doesn't tell us what speed the subway car gets to. It says it does reach its maximum speed and then it travels at this speed for a while. So once it reaches the maximum speed, it's going to travel at this speed for a while. Okay. Remember, we talked about if this would have said distance over here, if you have a flat portion of your graph, if it says distance over there, that means you're not moving. But if it says speed over here, a flat portion of your graph means that you are just keeping that same speed. And so we are still moving. We're just not gaining any more speed or losing any speed. And then it says it travels at the speed for a while, and then it slows down at another, again, a constant rate until coming to a complete stop. And so it's just going to go right down to the axis all the way there because that's when the speed would be 0. And so it's stopped at the beginning of the story, it's stopped. And at the end of the story, it's stopped. Okay. You guys have any questions on that?
No, sir.
Okay, that one's fairly simple, not super complicated on that one. Let's look at the next one. As television size increases, the price increases at an increasing rate. It increases at an increasing rate. So it's going to be nonlinear. Okay, it's not a constant rate. It's increasing at an increasing rate. So it's going to start off with kind of a slow increase. Okay, it's going to start off kind of slow, and then it's going to really start to pick up and increase. The rate that it's increasing is increasing. So it's going to look like, I should probably just start over. It's going to look like that. That's what it looks like to increase at an increasing rate. It starts off kind of slow. In fact, maybe I could even make this a little bit flatter. maybe a little bit wider, maybe that's better. Starts off kind of slow, and then it starts to pick up at that increasing speed. And so a reference I have to this, again, if I look at the bottom of my notes, you guys should have taken a picture of this yesterday if you were in class. We know that increasing at an increasing rate is going to look like that right there. So that's really all I have to draw, because that's all there is to this story. And if you think about that, that's true, right? If I went out and I said, okay, I need to buy a 20-inch TV, I could probably get that for cheap, right? Real cheap. Even like a 32-inch TV, you could probably get for a couple $200 or something. You start getting into the bigger TVs, you're looking at, like a 55-inch TV, depending on the brand, you're looking at quite a bit more money. You go to 65-inch TV, that's going to be a lot more money. 75-inch TV is a huge amount of money. And then they've even got like 85-inch TVs I've seen, and those are like $3,000. And so, yeah, it starts to take off at an increasing rate. Yeah. The next one, example C, a fully charged battery loses its charge at a constant rate until it has no charge left. You plug it in and recharge it fully. Then it loses its charge at a constant rate until it has no charge left again. Okay. So I didn't see anything in this story that made me think that it was going to be linear or non-linear. Everything in this looks like it's going to be linear. Okay. So if it says it's fully charged, then where do we need to start this?
The origin.
At the top.
At the top. Yeah, if it was at the origin, that would mean it has no charge. So I don't know what the top is. We'll say the top is kind of up here, and it's going to lose its charge at a constant rate. So that's linear until it has no charge left. So that would be all the way down. So then it's going to hit, I wouldn't say it hits the origin, but it hits right there on the x-axis where the charge would be 0. Then it says you plug it in and recharge it fully. Okay, it probably charges at a little bit faster rate than what it lost charge at. So I'll make that a little bit steeper. I don't know, I feel like my iPhone charges faster than what it loses its battery, but you guys use your phone so much, maybe that's the opposite for you. And then it says it loses its charge at a constant rate again until it has no charge left. So here I'm probably going to try to keep this line parallel with the last one. I guess it doesn't have to be. The story doesn't say what we're doing. It doesn't say if this is a phone. It doesn't say if this is a laptop. It doesn't say if it's an electric car. There's nothing it says about what it is. It also doesn't say if we are using it using it as much. So, if I'm using my phone the entire time, the first time around, and then not using it very much the second time around, it would obviously not lose its charge as fast, but more something like that. But we have no reference. So again, this is just a sketch. And so I'm going to sketch it. It would look like this.
Mr. Bright.
Yeah.
So for those questions on the homework yesterday, where it went like down, but then it didn't the line didn't go back up. It just stopped. But then you went higher up and there was a line going down, but there wasn't a line connecting them. Say on that one, you just had the two lines going down and not the line going up. There was questions like that on the homework yesterday. What?
With no line connecting them?
Yeah.
Oh, wow.
And it said it decreased instantly or increased instantly, which was what it was.
Remember that one, Cooper. We'll take a look at that one after I finish the notes here. You're talking, this is 6.5 homework you're talking about.
Yeah, I got it right, but it was it decreases instantly or increases instantly is what it said.
That's interesting. I'll have to look at the context of the whole problem. So here in a second, we'll look at that and see why it's decreasing instantly. Okay. All right. Example D says, as the available quantity means the amount of something. As the available quantity of a product increases, the price decreases at a decreasing rate. So as quantity is increasing, so we're no longer tracking time on the x-axis, we're tracking quantity available. So as the available quantity is increasing, so as we're getting farther to the right, the price is decreasing at a decreasing rate. So I don't know what it's starting at, but it's not starting at 0 because it wouldn't be able to decrease from there. So maybe we can start at, I don't know, right there. We'll see. And then so if it's going to decrease at a decreasing rate, that means it's going to start off with some steep decrease, and then it's going to start to flatten out. It's going to decrease the level of decrease. And so it would look something like, well, it's probably pretty close. It looks something like that. No, it wouldn't. It would actually, it would go straight down. It wouldn't have any sort of plateau right there. It'd probably just go straight down like this. Yeah, that's what it should look like. And if we double check, we can see decreasing at a decreasing rate. Yep, that's right there is what it should look like. Okay. And so if we think about this story here, as something becomes more available, it's going to lower the price. Think about, I don't know, maybe like the latest cell phone, the latest iPhone gets released, and they're going to charge a lot for it because nobody has it, right? And everybody wants it. And then once people start to, and I'm sorry if you're not an iPhone person, I'm not.
Oh, I totally am.
Apple related or anything, but I'm just using an example. As people start getting this and times, there's more quantity and people already have it, then they're going to start giving you discounted prices because they still want to sell it, but they've made more than what people need right now. And so it's going to start to level off. Now, it's not going to probably go to free, right? Nothing's free. So I'm not going to say it's going to go all the way down to the x-axis where the price would be 0. But it is going to level out. Okay. And you could say that about an iPhone. You could say it about just about anything. Any new product when it comes out is going to be in high demand because there's not much of it. And then once it gets, here's an example.
Toilet paper when
Toilet
COVID
paper. Yeah.
started.
During the pandemic, toilet paper, I won't say the price necessarily increased in the store, but there was definitely less of it. So if you were to go to eBay, for example, and buy it off of somebody, they're going to charge you more for it because they know it's in demand. Once they start producing more, because they did, these companies, the pandemic kind of shocked everybody. Nobody knew what was going to happen. Nobody really knew why people were buying toilet paper anyways. It wasn't like
the reason they were buying toilet paper is because they thought an asteroid was going to hit in April and paper beats rock.
Oh, okay. Good to know. So Caleb's got some toilet paper there. He's going to sell his for $4 a roll. No. But anyways, yeah, so they started making more and more of it. And then as people stopped buying it, they had the surplus. And so it obviously dropped that price back down to where it should have been. So in that case, the toilet paper would have gone like this, would have had one of those things where the price went up and then went back down to where it should have been. But anyways, okay. This next one says, describe the differences in each graph. Now notice that the y-axis in the first graph is the distance axis and the speed axis. So when I'm graphing distance over a time, this is actually going to tell me the speed. This is going to tell me how fast I was going. Okay. Whereas if I look at the speed one, it's telling me, I shouldn't say how fast I'm going. It's gonna give me a good idea of the different speeds I have. Whereas here, this is going to be the increase in the speed, not so much the distance. You're not increasing your distance. So if I look at the distance graph, my distance. Whoops, I want to use my highlighter. My distance is increasing, and I don't know what this distance is from, but it's increasing. So that means I'm going somewhere. The steepness of the line would determine how fast I'm going. If the line is not very steep, I'm not traveling very fast. My distance is increasing at a slower rate, still constant, but slower. Whereas if it's really high or really steep, the slope's really steep, that would mean a faster speed. What's happening right here?
You level out.
Okay, so
or you stop moving.
Yes, that's good. Yes, we stop moving. That's important to know. And I think I had you guys write that in the top page of your notes, but I'm going to write it again here. So yeah, you would stop moving right there. That means your speed has stopped. You have stopped. And then now this does not mean your speed is decreasing. And so that's why you have to think about what this is telling you. This means your distance from home is decreasing. It doesn't mean that your speed is. Whereas over on this graph, that's exactly what it would mean. This just means looks like these slopes, although one's positive and one's negative, it looks like they're about relatively the same steepness though. And so that just means you've taken off again and you're driving closer. So let's say you start at home. You drove somewhere, you stopped. Maybe you went to the grocery store and you stopped for a little bit. You start driving back and you said, you know what, I'm going to visit my mom. Or, well, you guys live with your mom. You're going to visit your friend. And so you decide, I'm going to make a stop. Again, we're not moving again right there. And then you are going to end the story where we started it, which is wherever that was, in this case, home. Okay. So the big difference here is that you're not moving on these flat sections. If we look at the speed one over here, you're moving basically the whole time. The only two parts of the story where you're not moving is right here and at the end. Those are the only two times that you're not moving. Okay. So when we look at the first portion, our speed is, I guess we could say, slowly increasing. And then all of a sudden it starts to rapidly increase for whatever reason. And I don't know if you're driving a car, riding a bicycle, maybe you were walking and then you decided you're going to jog. Okay. And then, so I guess if you look at this graph, what's going on right here? Does this mean we're not moving?
No, it means your speed, like you stay the same speed.
Yeah. In fact, maybe we could even say you're cruising.
Yeah.
I don't know how to spell that. So anyone who knows how to spell that for sure, let me know if that's wrong.
I think that's right.
Okay, so you're cruising, right? So there's a difference where on the first graph, any horizontal segment, any flat segment meant you weren't moving. On a speed versus time graph, that just means you hit the cruise control, right? You're driving or you're walking or you're running at that same pace. And then this did not mean we were slowing down on the first graph. That just meant we were getting closer to home. This absolutely means we're slowing down. Okay, and we're slowing down about the same steepness, about the same rate that we are increasing our speed over here. So I would say almost like a rapid slowdown right there. Okay, so I'm going to leave those two parts highlighted because those are the main differences in these two graphs. And then obviously we have this part right here, which is going to be super helpful if you have to sketch, and you will have to sketch a graph on the test on Tuesday. So any questions over the notes before I look at some of the homework questions? I want to look at the one Cooper was mentioning. Anyone have any questions first? Okay. So we'll look at the 6.5 notes. Cooper, do you happen to remember what problem that was?
No, I can see though.
Okay. If you look, the first several problems all are related to this graph here. Every single one of those sections is linear except for part E. So can someone describe to me, would part E as an elephant, would that be an example of increasing at an increasing rate or increasing at a decreasing rate?
Increasing rate.
Increasing rate.
Increasing at an increasing rate. It starts off with a slow increase, and then at the end of it, it has a more steep increase. So this would be an example of increasing at an increasing rate. Every other part of the graph is linear. And so it's going to maybe have a different description. Ashton Castillo, I see your hands up. But I don't know if you can talk. Yeah, I don't think his Zoom got fixed. Ashton, email me what your question is. I'll leave my email up here. Gotta minimize, get this out of the way. Maybe he already did email, not yet. Yeah, email me what your question is, Ashton, and I'll come back to you. Okay, so Cooper, I cut you off. Did you figure out what problem number it was?
No, but I know it's like further down the line than that. It's a couple problems later. It's like one of those same. Yeah, it's that one. It's that
Number
one.
11. Okay.
Yeah, question 11. That's what it was.
All right. So this is an interesting one. And it's all about context here. So if I was doing, let's say I was doing a distance over time graph, the reason that even if your speed was increasing very quickly, it never went straight up and down. And the reason it didn't go straight up and down, like if I was like taking off and like, okay, now I'm going to go really fast. The reason it would never go straight up and down is because that means no time has passed, and all of a sudden you're at a completely different location. And so that means that you would have transported. And that technology doesn't exist yet.
You teleported.
Teleported, yes, teleport. That's the word I'm looking for. Yeah, and that technology doesn't quite exist yet. So you won't see that on a distance over time graph. Okay. Now, what's interesting is you kind of have these vertical segments. If you were to connect them, there'd be vertical segments right there. Okay. And so it's all about context. You're talking about your hair. So can someone please explain to me what's going on right there and right there?
They're cutting the hair.
Yeah, it's a haircut. Like literally, they've got your hair and then scissors, it's gone, right? So they've cut your hair, and that's why that length is decreasing at a instantaneous, because it literally is just the top of the scissors. So that's why they have that there. As to why it's not filled in, my guess is because since we've talked about functions, we know that if they would fill it in, it all of a sudden wouldn't pass the vertical line test, which is probably why they didn't fill it in right there. Okay. So you said you got it right. It says the hair length blanks, then blanks, then blanks, then blanks, and then blanks. Interesting. Okay, so it increases at a constant rate. I think there's one that says that. Yeah. So it increases at a constant rate first. And then what would you put for the second spot? What happens? Haircut, right? What would you say? Is it decreasing at a constant rate?
At a instantly.
Instantly, yeah. So instantly right there. And then it increases at a constant rate again. And then it decreases
Instantly.
And then it increases at constant rate again. That's just the story of your hair right there. So unless you decided you're going to let it grow out, in which case that bar just keeps going until you get it cut again.
Unless you never do.
Or you never, yeah, or if you never do, or which at some point it's probably going to stop growing. I don't know. I don't know what that, I know that it just slows down. I think this.
It'll probably just fall off.
Well, yeah. When you're, maybe 80 years old and start losing your hair or whatever. But any other homework questions on 6.5 or even 6.4 that's due today? Or on the practice test that you guys started? We got a few minutes. I can look at anything you want.
Mr. Bright.
Yeah.
Are we just gonna turn in 6.4 work paper when we get back, or?
Yeah, that's the easiest thing to do. Instead of
do you
trying to
want us
have
to-
everybody email it to me, we'll just turn it in. Assuming we're at school Monday, we'll just turn it in Monday. And if not, we'll turn it in Tuesday, and we'll have one of those massive workday collections like we did later this week. So yeah, so 6.4 is due today. I extended the deadline to 4 p.m. I'm going to go into big ideas and extend that so it doesn't show up as late. So I gave you a little extra time since you probably slept in a little bit. And then 6.5, this homework is due at 2:30 on Monday, so when we're back on school Monday. And then tonight's homework, there isn't really, other than obviously finishing this lesson, there's nothing else because tonight's homework is the Chapter 6 practice test. And it's just reviewing everything we've done about functions. Is it a function, writing functions, comparing functions, looking at some nonlinear functions, and then like this section here, analyzing and sketching them. And
Mr. Bright,
yeah, you check.
number 2 on the practice test, how are we supposed to show that on a walk? How are you going to show that walk?
I thought I had the practice test on my iPad and I'm not seeing it. So let me pull it up here. Okay, I gotta log into Big Ideas so I can see the question. Nuche, there are gonna be questions. My guess is there's gonna be questions where you just aren't gonna be able to show any work. We've had those. We've had several of the assignments from this chapter. We didn't have to have a work paper for. 6.1, didn't have to have a work paper, and then the one we ended with 6.5 also does not. So this one over sketching graphs, that one doesn't need a work paper either. Let me go ahead and open it up and then share my screen. Okay, I'm gonna have to minimize you guys so I can see the screen. Okay, all right. So number 2, I see. So what I would do is in the order that they're in here, Nuche, I would say, I would write on your paper, I would put A, B, and C on your paper. And then next to A, I'd either put function or no function. For B,
Okay.
I'd put function or no function. For C, I'd put function or no function. And then you can just drag them and drop them to where you want them to go. Yeah, so
Know which one's A, B, or C.
whatever, the first one's A, middle one's B, last one's C. So
Okay.
let's just look at A right here. Do they have any inputs that are going to 2 outputs?
Yeah.
Yeah, they do. So that would be a non-function. Yeah. What about the B? Is there any inputs that are going to multiple outputs?
Yeah.
Yeah, that's a non-function. Okay, what about C? Any inputs going to multiple outputs?
No.
Let me rephrase.
No.
I should say, is there one input that's going to 2 or more outputs? The answer is no. 4 and 6 are both going to 8. 5 and 7 both going to 10. But because 5 is only going to 10 and 7 is only going to 10, that still works. This is still a function. It's when 4 goes to 2 different outputs, like here for number 1, the number 1 here. So yeah, easier to do on your iPad than it is to write it on your paper. For number 1, you would just write down the ordered pairs that work. Like you're just checking them off, like which ones are real and which ones aren't real. Just write the ones that work. So, yeah, any other questions on this practice test while I got it pulled up? I don't know how much you guys have started on it. Like this one here, number 5, you can just literally write no work. The equation's already in slope-intercept form, so you don't need to write it in slope-intercept form. It's already there for you. Just have to graph it. And then obviously here, you're going to write your functions in slope-intercept form. If it's a linear function, you need to write it in slope-intercept form. Nuche, for number 9, I would do the same thing. I'd say A, B, C, D, E. Linear, nonlinear, whatever, just kind of write. And you can even use L and NL for linear, nonlinear. You can use much abbreviating as you want to. Yeah. It's 10:45, so the lesson's technically over. And at this point, you guys are just kind of working on homework. So Claire, you still want me to, are you still with us, Claire? Where'd she go? Okay, well, does anyone want me to create a breakout session, or do you guys want to do that yourselves and kind of call each other if you want to work together on it? I don't care, but what do you guys think?
I'm gonna work by myself.
Okay. Well, if you guys want to work, like I said, if you want to call up your buddy and work, it's fine. As long as there's a difference between working together and copying, obviously. I don't want one person doing all the work and someone not learning anything from it. So put your heads together and you guys can talk through the problems together. I've got no issue with that. And then you have to have your separate work papers to turn in when this is due on Tuesday. So I'll go ahead and end this lesson and send out the recording, and I will see you guys hopefully in school Monday. So have a great e-learning day and a great 3-day weekend.
You too, sir.
Thank you. See you guys.